Hello mortals, Bartosz here. This is 10th devlog of the computer RPG game Meonlawel. I'm writing for the last 100 years already, and I'm probably going to continue for another century. So, if you see this video in 100 years, I hope you really like the game and you have fond memories. Okay, today I wanted to talk about the memory organization. Why it happened that I started to work on this is simple as that I had no more memory left, no more free space to create new functions and also put some items and graphics. That's why I needed to technically rewrite part of the game. So this is the topic I wanted to share with you about the memory organization and the chicken egg problem that I had by doing it. So let's start. Okay, I will show you the memory layout. This is a README. I'm trying to always keep up to date. So as you can read over here, I have 22 kilobytes of memory available for program. The rest is taken by the things that are used for the game as well, but you have things like fonts, level, and some players inventory and so on and so on. So for the actual code I have only 22K of memory, and this is not too much actually, especially that I have locations, I have battles, I have title screen and so on and so on. I started to see that the space is going down very fast. And at some point my compiler just got stuck because I have some warnings over there, and in case that this area will be exceeded, the compiler just not compile, and then this problem started to show up quite fast during the development, because this is still an engine phase of the game. So then I started to think, how can I make it better? How can I improve this and still fit memory? So one of the first things I introduced was to create a core. This is like part of the program that is used everywhere by all different components, and then I designed some memory layout. So for the core I thought like, I can actually just keep it here in this memory location, and then everything which is used by the core can be loaded from separate modules. So then I thought about something like swap modules, just to introduce swap modules that can be swapped. Depends on the actual context and the actual mode of the game. So then I thought, how many swap modules can I have? And then I noticed that actually there are parts of the game that are used only when player is in the location or when it's in the battle. So then I started to split it by functionality that is available in one or the another context. Then I noticed that of course there are a few things that I need to move to core because they are used by these both modules, and that's pretty fine. That's what I wanted to achieve really. And then I started to see as well that I have title screen. And title screen, I don't need to have it in memory when I'm playing the game. This can be also removed. So this way I created 3 modules so far. I don't know if I can show it that fast. Okay, it's here. So in battle, this is one of the modules. In location, this is another module. And I have a title screen module over here. And all of them, they can be swapped, depends on the context. This is done automatically by code, which resides in core. And core is the one that is always available. So you can see here I have a swap module request. In case there is a request, then I'm going to the controller, and the controller does the whole magic to me. So I can add the list of different modules, and the whole thing just works automatically. I don't have to think about it that much. Okay, so that was fixed. But then this memory also started to go down very fast, because I started to add new items and new magic books and so on. This list is quite short at the moment, but I already assigned some memory space just to see how much of the space do I need. And then I noticed that I'm going to do something, because I don't have even memory in the swap modules, not even enough. Not enough, so I have to move some portion of code out of these modules. So then I started to think about it. Yeah, data is something which is really not core, or it's not like a module functionality. It's something completely different. It's something that should grow as game progresses. If I want to add another book, a magic book or another item, then I should be able to do it. But the module itself that contains functionalities, it shouldn't probably know even that there is another item or another book or another equipment to be added. So then I started to think about yet another portion I could just split and remove out from the module, and that is something I called packages, which is a little bit, I'm not sure about the naming, but as long as I have a readme here and I'm updating it, I can follow the logic I have created, and remember about the rules and about the constraints, because there are all, of course, some constraints by doing memory swapping, and I'm going to talk about it now very shortly. So first thing is that the package is something, I'll show you one for items, for example, that contains data for all weapons, for different attributes of these weapons, like attack points, defense, or dexterity, luck. So there are many different tables here, and yeah, this was the part of the module. And then I decided that yeah, the module really needs to be freed out of this part. So then I move it out just to this package, and I thought, yeah, this is as simple as compiling this portion of the code. But then I started to see that it's not going to be that easy, because this package uses some functions and variables that are available in the core. So there's a reference here, and for example, if you have an animation for character, heal single character animation, then this one actually contains some calls and uses some variables. For example, this is a function that exists, a procedure, function, you name it, that exists in core. And the same for others. So yeah, I was not able to compile it because I needed to know where the address actually resides. In order to do it, I have to compile the core first. But then the core as well references the package, because if you look here, for example, for the names, I want to list all names of all items I can use. And if I look in the code, let me do a quick search. You can see that actually this is in the dialog box that I'm using to display names. I'm referencing to the address that is not in the core because I wanted to move it out to the package. So then I have a chicken egg problem situation here, because I cannot compile core first because it references something which is only available in the package. So I have to compile package first and get the labels out of it and use in the core. But then I cannot do it as well because it packages, coding packages reference the core. So yeah, this is something which really took me a while to try to find a solution. I thought about using some tables with addresses so they could be like an intermediate, like a lookup kind of way of finding the correct place where the table resides in the package. But then I thought this is probably error prone, because I have to be careful that these tables will always point to the right addresses and I have to update them accordingly. And in the past I had issues like building the structure. So you can have a quick overlook of build. This is all stuff which is built. So in the past I used some labels created by other packages, but then I realized that actually I'm using these labels from previous builds. So then I didn't have this chicken egg problem, but I found that there was some address which was old, and then I noticed that actually I have to remove this whole build structure every time I'm rebuilding the whole project and I'm compiling the whole project, because then some labels they are actually not present. I noticed that they were just the labels from the previous build, and then yeah, this chicken egg problem arose. So in other words, I needed to find a way of creating labels that I can use in another compile. In this case, from packages, I needed to use these labels from packages into the core, compile the core, and then recompile the package again with the labels from the core. So then I can have both things working. So this is what I did. It's a little bit, it feels like a little bit hacky, but actually it's the easiest way I found. So I will show you the make linking procedures I have done in BAT. Welcome in Windows World. So this is this compiles actually the package first, but with fake labels, which means that if I go to the items package here, yeah, a lot of lines of code already. Yeah, let's go up, and then you can see that The first compile pass will be using the fake kind of labels. This is something which is in the air. There are not really addresses that this package should use. But for the first pass, I'm going to just say to compiler, yeah, let's just use these all functions you need in this package. So I have to list them here, and this way I can compile this package. It's not fully working, but what I can do is that I can export all labels from this package, so item, weapons, lag, and so on, and use them in the core package. Then in the core package I can compile it, because then I will have the core package working with labels from the core package. So after exporting these packages from the core, which I'm going to compile here, I can use these labels back in the items package. That will now work correctly, because I'm not going to pass the flag. So now you can see that I will just include the labels from the core. This is something which is not available from the start, and all these addresses will be fixed. So this whole thing works. I'm also using a trick that packages, they actually are running in the cartridge location, which is another limitation I needed to go over, because I really didn't have place to load packages into memory. So I decided just to use it straight from the cartridge. Of course, the main downside of doing this that way is that I cannot modify code that is running in the package. So just to show you an example of one of the spells, this is the one that is in the package, and this is a spell called Decay, and there is a call here that requests to play the animation. Actually, this is to end the animation, sorry. After 100 times it's going to finish it, but there is where this animation is set for this spell. So you can see this is actually the function that is running from core. This is going to call it from the core, and then I can add here animation. Let's say that I want to flash the board for 100 times. Let's recompile it. Everything is built from the scratch, and now as you see this dialog box, this is something which is used for both packages. For items it's sorry, not for packages. It's a module. It's used for both modules, for locations and for battle. So that's why dialog box is actually in the core. So all these fonts and the way how it's shown, this needed to be extracted to core. But talking about packages now, these names are already taken from packages. So actually I'm switching to packages just to read that from ROM. And Decay, this is the spell I wanted to show you when I will execute it. Then you can see the board flashes, okay? So this is the same for items. If I have an item, there's an animation actually here. This all runs from the package, and the package runs from ROM. So actually I'm running it straight from the cartridge. How I achieve it is that I'm switching the ROM low on, so in area from 8000 to 9FF in hex, this area is then visible as ROM, so then I can actually get to the code and I can read the code here directly from the cartridge. So this way I decided to go with packages. For modules, they have to be loaded into memory, but for packages I decided that as I don't have any more free space, and this is mostly data because it uses a lot of tables, this is used for lookups. I don't really need to load it anywhere. I decided to just go with this solution, and as long as it uses also some animations, and there is some code, but still I try to treat animations as part of data. So I think that's all. So the chicken egg problem is solved. It's kind of elegant way, I would say, because I'm always sure that these addresses, they are correct ones, that the core always refers to the correct spaces, and also that the package, each package also does the same. So yeah, I guess it's going to work, and now I can progress on the game, on the engine. So that's all for now. It's already a long video, so thank you for watching and see you in the next one. Bye bye.